My name is Jason Davis. I'm one of the VPs of product management at Sauce Labs. Today, I'm going to talk to you a bit about API testing, where we at Sauce Labs see API testing fitting in the software development lifecycle, and how folks, both API developers as well as QA teams, can use things like OpenAPI to drive kind of quality testing. Sauce Labs is a company, if you're not familiar with us, over a dozen, maybe 15 years old now. The company started as a platform for running cross-browser and mobile emulator, simulator, and real device testing. In fact, the folks that developed the Selenium open source testing framework started Sauce Labs 15 years ago to provide a cloud infrastructure for testing web apps. Over the decade, a decade and a half, the company has grown to focus not only on infrastructure, but over the last few years, really build out a set of capabilities for testing, not just end-to-end functional tests on your browsers and apps and mobile devices, but also things like API testing, crash and error reporting, visual testing, and a slew of other kind of tools that developers and QA teams need to test the quality of their applications. So it's a really interesting company to be a part of because we're kind of at this pivot point now where a lot of our historical customers have really focused on using the cloud automation infrastructure to test the front-end apps. And now we're starting to get into this notion of doing component-style testing, as well as just discrete portions of your app, getting into API as an example, as a way to isolate where test failures are. Right? So in the 25, 30 minutes that we have here, I'm going to spend 5 or 10 minutes talking a bit about market dynamics, what's causing folks to use things like API testing now instead of just end-to-end functional testing and those sorts of things. Then we'll spend some time talking about what Sauce Labs provides specifically for API testing as a platform, as well as how we use OpenAPI and specs to help bootstrap and quickly create tests that are driven from the specifications as well. And then finally, we'll close talking about the rest of the Sauce Labs platform and how we see different tooling coming together to develop what we're calling the DevOps test toolchain, which allow you to collect different quality signals throughout your software development lifecycle to isolate where errors are. So first, a bit about market dynamics, and I have a few things up here to discuss. First, kind of an oxymoron, right? Nobody likes to change, but we don't like to stay the same. And some recent surveys from Kong. In fact, I think Kong has their event coming up next week as well, but they put out a nice report every few years around the pace of technology and so on. And what we see here is that technology leaders fear they're going to be left behind because of the fast pace of change with competitors. I'm sure you see this in your organizations with your management and leadership asking for dates and trying to move things along as quickly as possible, have as iterative releases, test, and see if we can stay ahead. But we see this in business as well, right? Just last week, Figma, as a company that now provides web-based creation tools, was bought by Adobe. And why is that? Adobe's huge, but they're losing ground to the competition that is very quick and nimble, able to incrementally release capabilities, have a web-based interface to support collaboration. Because design, much like testing and development, doesn't happen in isolation. I need to collaborate. Right? So we see companies acquiring other companies because of this fear of competition. Microsoft bought GitHub a bunch of years ago. Same thing, the fear of losing the developers. Where are the developers living every day? So acquiring your competitors is one approach here. But the other approach is, again, as I said, how do I build things incrementally and quickly and test them and find out if we can get ahead of the competition? And APIs are a great way to do that because now we have, it's not the only path, but it's an incredibly easy path to have one service expose a new piece of capability and then test it with a group of users. So we see that this market dynamic is one of the things that's changing the way that we build and test applications, allowing you to quickly iterate and release new capabilities. The second thing that we see in the market, and it's outside of our core pieces of building the APIs themselves, but it's where do the APIs surface? They're not only in like service-to-service types of communications, but ultimately in end users' hands when they're using mobile apps. And in Sauce Labs, we've focused on testing these mobile apps. So over time, we have seen in our reports, and again, in the Kong reports, that, and this shouldn't be a surprise to anyone, users are fickle. And we're all users today. We use mobile apps all the time. If an app that I don't absolutely need to use, like my banking app or my flight scheduling app, if that app takes too long to load, I am going to remove it from my list of apps that I'm using on a daily basis, right? Now, again, Sauce Labs, we've focused on testing mobile apps to try and address this problem. But what we start to see is when apps get started, if I'm trying to find out why is it taking so long to load or why is it crashing, it's not always within the app itself, right? These mobile apps all have backends that they're communicating with. So today, and what we've seen over time, is folks do end-to-end functional testing, and when they see an error or processes taking too long to execute, they then spend time trying to isolate where the problem is. And I like API testing because it gives us a way to isolate that type of communication away from the actual application itself. So we've started to see customers start to embrace API testing for this very reason. And I'll talk a little more about how we're making that pretty easy for not only API developers, but QA testers as well, so that they can take their kind of end-to-end mobile app testing and identify what are the API calls that are being used in the background, pick those up and bootstrap some API tests. Right, so I'll talk a little bit more about that, but we see that as a driving reason for why people are starting to move towards different types of testing methodologies. The third thing that we see is this notion of microservices. And again, everybody here being API developers, I'm sure you're working on small services that are discrete, that provide certain pieces of functionality. And you probably have dozens, if not hundreds of those in your organization. In my 20-plus year career now, I've seen this transition as well, especially over the last 15 years or so, where we no longer have monoliths. Within Sauce Labs and different applications that I work on, we have dozens of these microservices, and we see this problem today. A good example of this is I have one of the applications we have is a crash and error reporter. And that is made up of dozens of services where first I have a submission layer, and all it does is accept crashes and errors from clients and then routes it to a particular instance. So one service that just handles routing. And there's another service after things are indexed to support collaboration. Somebody sees a crash or an error and they want to make a comment on it. We developed a comment service that was completely independent, that had its own set of APIs, and all it did was allow people to comment on these errors. There's another service that's an alerting service that sits there, and all that does is look to see if there are rules being met to drive alerts somewhere. So we see these microservices being created, and as you create dozens of them and so on, the set of complexity starts to explode. So we need approaches and techniques to test these in a more effective way, right? And I'll get into what we provide here, but one of the kind of the key capabilities that I've seen in this area is the ability to automatically start to monitor these microservices, both for uptime as well as for ensuring that the contracts are still adhering to the specification that's been defined, as well as functional testing that we can do to see if the business logic is still taking place the way that it should. And having that automatically done for every microservice that you stand up is a nice way to address this need of the explosion in complexity. So at Sauce Labs, we've taken some of these market changes and we looked at our customer base and seen the increase in testing on mobile applications. So rather than addressing just API testing specifically, we've taken an approach of starting with mobile apps. And the reason for that, a few things that come into play. One, if you've worked on mobile apps or you use mobile apps, you know that you can't really roll back. A new release is put out and you download it, but you can't go back to an older version if it fails. Not only that, there's a lot of time that's needed to get something published on the App Store. If you've ever tried to publish an app there, you know it's a 5 to 7 to 10 day delay before things get published. So this brings in the need for having more testing of your back-end services, of your application itself, and making sure that it's living up to the quality that you expect before it gets released. In addition, you've got complex and unpredictable stacks. iPhone makes it nice and easy. I have just a small set of devices and operating systems I need to deal with, but with Android, we've seen the proliferation of different device types and different versions. And not only that, we also see in different areas around the world the quality of devices and the generation of devices that are used. A nice example here in the States and in Europe, we often see some of the more powerful devices in the majority of users' hands. But once we start working with folks in India and South America, I often see older devices with limited amounts of memory and older chipsets. So in the past, before our customers started branching out in those areas, we still had unpredictable stack because we had different types of devices. But now, as we start to see some of these lower powered devices, the need for testing becomes even more important. We find, I do a lot of work with video game companies and people that are building mobile video games, and they often find that once their users are running things on low-powered devices, the games don't perform as well as they should. Again, increase the need for testing up front, understanding the types of devices that are going to be used is one of the reasons we wanted to start with mobile. So again, with mobile for us, it's about the APIs within the app as well as the APIs in the back end, and that's what we're looking to provide a set of solutions for. Now, it's not just for mobile. This is just our approach because we want to have a nice end-to-end experience that fits in with what we're seeing with the number of our customers. So before I go into what Sauce provides, one more step back and trying to think about where your organization fits on this model of risk tolerance and the ability and how you release your applications. So as a product manager, I love 2x2s, and what we have here is a nice 2x2 graph that shows on the vertical axis how folks deliver applications. Right? At the bottom, versioned applications. At the top, more continuous release processes. Right? Your horizontal axis here is around risk tolerance. And the notion of, are you focused and your organization focused on code coverage, or are we focused more on getting things released quickly, having high risk tolerance, and being able to address those problems? So I've found organizations really fall in each of these different quadrants. At the bottom left, the main primary concern is around our teams behaving the right way. You'll see this at organizations that have waterfall models, where there's very hardened specs that are written up front, where we're releasing maybe monthly or quarterly, where you have a centralized QA team, and that allows you to, with those rigid specifications and a central QA team and version software, you do a lot of testing prior to release, right? And there's a lot of control in terms of how teams are behaving. If I move a little further on less on code coverage and more towards an organization that has a higher level of risk tolerance, we see folks that have multiple developer teams operating in this way. So usually I see organizations following like the SAFe model here, where they got scaled agile frameworks. And their focus is on, and their primary concern rather, is on, are they making the right investments? Are they planning and making investments in the right way? So here we see folks that have higher risk tolerance, so they're releasing more on a weekly or even a daily basis, and their ability to roll back their changes is there. So when we think of these types of organizations, there's a little less on the requirements side that's put up front, but they still have central QA teams that are focused on making sure the quality is there. As we go higher in the quadrants, this is where we see more Scrum and Kanban, where there's less focus on versioning, and it's more about the developers quickly building and iterating on their capabilities and releasing to market quickly. The primary concerns on the left, we see folks looking at defined guidelines. So the idea in Scrum, for example, do we have a common definition of done? And then there's a guideline of what are the things we need to do to say this thing is done. Has it been tested in the right way? Have we gone through systematic ways of testing the capability? And there's a focus on management, making sure that we understand, again, the guidelines that are defined and how people are executing them. And then further on the right, this is where we see more Kanban model and folks releasing on a very regular basis, maybe hourly even. And there's high levels of risk tolerance because they're doing things like experiments. We're running A/B tests here very typically and trying to see if a capability that's been released is actually up to the right level of quality for a certain set of users before they decide to release it further. So we find organizations really fit in any one of these boxes. And we think about the end user experience. What is it that the end users we want the end users to achieve? And then from there, work backwards to what are the types of tests that we need to invoke. So those are some of the market dynamics that we've seen that are forcing organizations to change the way that they test. So with Sauce Labs, what we want to talk about today is spec-driven testing and what we call our DevOps test toolchain. So before I even get into the spec-driven part of it, there are 3 challenges that we've seen, or barriers to developing APIs that have a certain level of quality. So the first thing that we've seen is it's difficult to create tests. You have tools, HTTP client tools, that allow you to view what your APIs are exposing, but they don't make it very easy to quickly create tests around those APIs that are being exposed. So it often falls down to either a QA engineer or a developer, once they're done building their test, to sit down and define their functional tests, their contract tests, et cetera. The second challenge that we've seen is low focus on reporting. So once I develop a set of tests, if I'm in an organization that has more than one team, how do we know, for example, if one of the services is actually at the right level of quality? Are the reports that are being generated exposed to management and to the other teams so that we can see where there are challenges? And we often find that these types of tools don't exist just yet, because I think API testing in general is still an area that is growing. There's a lot of change that's happening in this area. The third challenge that we see is around these microservices that are being developed and the low release, the confidence in release, because of the changes that happen as development occurs. So you might start with a certain specification, build your program, and then make changes to the program, but not go back and change the spec. And when that occurs, now we have drift from the spec. And when QA tries to go in, if they're going to build their test based on the spec, it's different than what the application does today. So this introduces a level of low confidence that we need to address. So the Sauce set of API testing really focuses on addressing those challenges. So the first is around, how do I quickly create tests? And instead of having to sit there and manually write tests based on the programs themselves or the specifications, what we want to do and what we've developed today allows you to automatically generate a set of functional tests and contract tests, as well as a mocking server based purely on OpenAPI specifications. So take your specification, load it into the tool, and we'll bootstrap for you a set of contract tests that you can use from that initial design period to make sure that you don't have any drift from what that design is. The second thing we've focused on doing is providing centralized reporting. Because we provide more than just API testing, we have an area within our app already focused on collecting test results, pass-fail test results, as well as the patterns that are causing failures along the way. And those reports are accessible throughout to folks within the organization so that we could see if the level of quality is what's expected. The third thing that we've focused on is ensuring that there is high confidence. And the way that we do this, again, is starting with these specs, generating the tests that can be used, and then running them on a regular basis. Sauce and the API testing suite provides monitoring and load testing, which gives us an ability to ensure that we have confidence by running monitoring across these services as soon as they're developed and released. So we think about API testing across the entire development lifecycle of building your APIs. And you might have some slightly different phases that you're focused on, but we often see design, development, documentation, deployment, and then monitoring as the phases that folks go through. So as I'm going through design, as soon as you have your first specification file, we encourage people to start testing that with contract testing to make sure that the request response is correct. We also ensure that you have a mocking server, so if you're doing consumer testing, you can have a mocked producer on the other side. If you're generating your production tests, you don't necessarily need the mock server, but you'll just have contract tests that can be running and testing against that. After you've gone from design and you start building things and start generating functions that are going to do whatever it is, add to cart, perform the checkout, et cetera, you want to generate functional tests that occur at the API level. And this is also what's kind of new for Sauce. Unless you're an API developer or an API QA person, you're often not building these tests at that level. especially in those organizations that have centralized QA functions that aren't really familiar with all the things you're building, they're going to stand up the mobile app or the website and start doing some manual and exploratory testing through the user interface. How do you take those types of functional and exploratory tests from the user interface and generate a set of API tests so that I can isolate the test failure? And that's one of the key challenges and things we set out to try and address with functional testing and integration testing. I'll show you in a little bit how we did that, but like I said, that notion of allowing a QA person to go in and manually test an app and then capturing the network traffic and API calls that are generated through that so that we can build tests was our approach there. The third area we see is once we get into documentation, contract testing comes back into play. We need to ensure that as we're documenting it, we're still adhering to the same specification, or if the specification changed, that the contracts still do hold up. Once things get deployed, we have regression testing that's in place. All of the functional tests that have been created can be scheduled and automatically run or integrated to your CI builds so that as you generate a new pull request or do a merge, you can decide what sets of tests could be executed there. Not only that, but you can identify pass-fail information and then decide, is this actually ready for deployment? Do we need to do a rollback or do we need to do a hold because critical tests are failing? This is also super important with microservices because I've got tons of different services I'm deploying at different times. So making sure that I'm testing these different services and the dependencies that I have is really important at this phase as well. And then finally, after it's released, making sure that it's monitored. Is the service still up? Is it performing at the right level? If we're expecting a flood of additional load because maybe we have a release coming up, how do we configure the system to test for that? So SOS has created a set of tools that allow us not only to monitor all of the APIs themselves, but also do the load testing on them, see what level it's going to hit before the performance starts to be impacted and so on. So as an API testing platform, this is what we set out to do, provide all the different types of API tests in one environment so that folks can build the different tests that are needed depending on what phase in the life cycle they are to ensure that they have quality. So we start from this notion of the OpenAPI, the spec files. And as I mentioned before, the main thing for us is you can take that spec file and import it into the SOS API testing suite. And we have a visual authoring tool that we can use to show you how the set of tests that will generate from those API specs. And that's a great way to bootstrap the system. You'll get a first set of making sure that we exercise all the right request and response calls. But it's not always as complete as you want it to be. So you're going to need to sit down as a developer or a QA person and extend the set of tests that are there. But the main thing that we focused on here is getting started quickly up front. So as soon as I have a spec, make sure I've got contract tests that are available and that I can run and test as I'm going through design and as I get back into documentation at the end. As I mentioned before, the mock server is really, the mock server, I'll talk about that again in a second, we call it Pystry, is a mechanism for you to take those same spec files and then have this mock server that will respond to requests with faked data so that you can actually test everything as if you had access to the producer, but without actually having the real data or the producer available to you. So here's a little bit more about what that looks like. Pystry is a tool that you can download from us and generate those contract test files to be used with your consumer or producer. This is also where the handoffs can be managed a little more seamlessly. I've seen organizations where the developers are fully responsible and required to run all of the testing. And a lot of the orgs that I work with start off with the developers doing that, but then having a handoff to QA. So we find that the mock server is a nice way to support that handoff and educate the QA teams on the capabilities that the APIs are supposed to be providing. It really helps to, as we say, eliminate the bottlenecks there, especially during transfer. We've got a lot of knowledge that needs to be handed off, and using a tool like this helps with that knowledge because it's not only documented, but they can see it in real life and use that again as a basis for initial testing. So a little bit of what this looks like outside of the OpenAPI side, because if I'm not developing with OpenAPI, there are other tools that I can use. FastAPI is an example of this. And FastAPI basically allows you to quickly generate a service. In this case, the service over here is listing out a bunch of different sauces, different hot sauces that are available. And the service will have some update functions and some getter functions. FastAPI makes it easy to expose these in a RESTful mechanism and then generate OpenAPI specs from this. With those OpenAPI specs, send them over to Sauce Labs, and now I have a mock server and a way to do the contract testing. We've seen folks start building new applications and within 5 to 10 minutes have their contract tests up and running, and this is the mechanism behind that. Okay. So all of these, the API tests here, they fit into a broader platform. API testing, there's a set of tools that you could use throughout the SDLC, but when we're testing our applications, it's not just the API, there's various other things we're looking at. We're looking at functionality, we're looking at visual consistency. Did the pixels move when they weren't supposed to? Is the image still the right image, et cetera? We're looking at unit tests and security tests and so on. And it's not only the developers and the QAs that are looking at these tests, but also product folks, support folks, et cetera. So this diagram here is meant to show kind of the breadth of testing capabilities that are available and where in the life cycle of your applications they're being used. So we have the notion of shifting left, testing early in my development life cycle. That's things like code coverage, contract testing for API, even visual once I have an initial design and I want to make sure that my implementation actually adheres to that design. And then as I go further towards the right, after my application is deployed, making sure that it's monitored, making sure that I'm collecting errors that happen in production, because you can't test everything up front and things are going to slip through. So how do we make sure not only that we get the proper reporting back, but also, I don't know if I have journey monitoring here, journey monitoring all the way over here. How are users actually using the application? Because even though I've designed it a certain way, we all know users are going to go off and do different things. So how do we take that knowledge of what users actually are doing, the 80% of the flows that they're performing, and use that to inform what it is that we actually test? So this is the vision for Sauce Labs, and you can see down at the bottom kind of where we rank ourselves now with our platform and the capabilities that are provided there. But this slide builds a little bit, and there's a really interesting point I referenced before around API testing, and how do I grow it so that it's not just my API developers that can test it, but what about my central QA team that has no knowledge of my APIs whatsoever, and all they're doing is exploratory testing or live testing, and they're loading up an emulator or simulator and running through the app. So the question we pose, what if I could take those end-to-end tests that we're doing, either on an exploratory model or I've written some automated end-to-end tests, and what if I can run them faster? Because those tests take a long time. They have to load a UI, I have to wait for all of the response, I need to wait for the screen to draw, I need to get the communication back and forth, all of that. So we find actually this is one of the biggest bottlenecks, and we're looking at API testing as removing that bottleneck. We're taking and helping the developers and QA folks take as much of the underlying API as they can and extract out the functional testing from their end-to-end tests and put it just in the API tests. So now that information is isolated. And if I have a test failure on functionality, I add it to cart and it didn't appear in my cart, I can see if that happens straight at the API without having to start at the UI and navigate down and try and figure out where that failure is. So for us, as we see this platform, and if I go back to what is Sauce focused on historically, we have these cross-browser mobile devices, mobile emulators and simulators that are available for folks, and that's where they develop a lot of their end-to-end tests. Now we use API testing to extract from that the communication between the client and the server, or if there's just straight API communication within the client, extract those calls out and seed some of those API tests so that you can, in fact, run them much faster. Other things that we look to do with this platform, app beta testing. If your organizations are building mobile applications, they probably use something like TestFlight or Firebase to do mobile app distribution. I want to circulate the app to 10 or 100 people and have them test it in a beta format before it gets released. And we have also seen a lot of complexities there because there are different tools that teams need to manage in order to support that mobile app testing. We've also built that into the platform now so that from those beta tests, when I distribute it to 10 or 100 users, I could start to understand how they're using the application and feed that in so that I have better automation in the future if I haven't covered the behaviors that they're performing. Error reporting and monitoring is very close to my heart. I spent 5 years developing the backtrace solution that we have for crash and error reporting. And this is huge for test right, both for mobile and web. As soon as the app leaves my device, how do I know what crashes and errors are occurring? As I mentioned before, we do this a lot for mobile games. If you look at any of the release notes for new releases of apps in the mobile app store or anything else, you'll see like top X crashes or errors that are fixed in this release. And that's what we look to provide with error reporting and monitoring. We found with our solution, we focus on fast detection and surfacing enough information to resolve those errors very quickly. And our customers tell us they're able to take the time it takes to resolve issues and cut it in half based on the information that we're providing. So after a bug gets released, as I said, those READMEs with the top 10 errors that are fixed, we're helping developers identify those errors and fix them in about half the time that they were before. 3 other things that we're looking to do with this large landscape here. I mentioned this before. We don't know how users are actually going to behave and how they're actually going to use the app. So journey monitoring, understanding what things the users are performing, the behaviors that they have, taking this in and using that to inform how we're testing is another way that our customers are starting to optimize their tests so that they test really what the users are focused on and not what they think is being used. I'm going to skip through this one and just focus on our last one here. All of the ilities, so vulnerability, accessibility, having observability into your system, what if we can provide that throughout the development lifecycle as well? We often find customers leave vulnerability analysis and accessibility to the very end before they release. And there's usually like a 1-month period where all they're focused on is accessibility or the vulnerability analysis. And that then ends up leaving additional time to fix problems because I'm not going to encounter them until months after I might have built the capability. So we're also looking at shifting this part of the testing further left. So during every merge or PR, you could identify what types of vulnerability scans or accessibility scans you want to run to see if any of the recent changes have had an impact on that. That's just a different way of testing because most folks don't have tools to allow you to do that throughout the CI/CD pipeline. So we're trying to focus on shifting that a little further left as well. Here's one other way to kind of look at this DevOps test tool chain as a picture in terms of the different phases of development. As folks are building, integrating, and then releasing, you need to have quality checks throughout those different life cycle areas. So starting with the initial development, having contract tests, then developing unit tests, visual tests, et cetera. We do see this as a cycle and a feedback loop, and that's what we're seeing our customers tell us as well. Not only in the development and integration phase, but as I mentioned, shifting right and in production, gathering this data as well and using that to inform your quality tests in the future. Cool. So that went a little faster than I thought, but I definitely open up the floor for questions if you have them. So let me turn it over to the audience here if you have any questions. Yeah. Yeah, no, great question. So the question's around, we can bootstrap a set of tests but what happens after they're bootstrapped? What do we see people doing with it? So the stats that I've seen, we see the bootstrapping as a quick way to get started, but inevitably they're gonna go in and edit those tests. They're gonna do, once they understand the business logic behind what it is that they're testing, we'll do things like including the proper sets of variables so that I can test for like looking up a certain type of thing with an expected result. I can capture that when I'm going through exploratory testing, but if I want to extend that and have different things that different values that I'm looking for, or different paths to edit the composer, the visual composer really allows you to extend that out. So we see folks getting started with the bootstrap tests, but very quickly they're going to go in and edit those to really fit their needs. Any other questions? Awesome. Well, appreciate your time. Encourage you to stop by the booth as we have the crawl a little bit later, and we'll be happy to talk to you a little bit more. Thank you.